All right, so we're looking at a test given, and we are examining the solutions that were done. So the solution for question 1 is C. It's a multiple choice for the first set of questions. F of x equals 3x minus 4, and the direction was to find the inverse of f of x. All right, so let's look at that. F of x is equal to 3x minus 4. To find the inverse, we need to do the following. Change f of x to y. That's step 1. Step 2, interchange x and y. Wherever we see y, we put x. And wherever we see x, we put y. That is step 2. So you can make note of that. Step 1, change f of x to y. Step 2, interchange x and y. Wherever we see x, we put y. Wherever we see y, we put x. So we have done that. Step 1, step 2. Step 3 now is to isolate y. Now before doing that, we want to isolate the y term. So that means we need to remove the minus 4. And after doing that, we remove the coefficient of y if it's not 1. So let's do the first thing. Let's isolate the y term by adding 4 to both sides. Minus 4 plus 4 will give us 0, which leaves us with 3y on this side and x plus 4 on this side. Now, to further isolate y, we need to remove the 3, and 3 is a coefficient, which means it's a multiplier of y, so we divide both sides by the numerical coefficient of y. That is 3. So 3 and 3 give us 1, and so we have 1y, our y is equal to x plus 4 as a quantity divided by 3. Then this y defines the inverse of f of x. Okay, and this will be the solution. C as a solution, and so that would not be correct. The answer should be option A. Question 2. The value of x that makes f of x equal the rational function x plus 5 all divided by x minus 3. Undefined, right? What goes in are the x values, what comes out are the y values. But what is that value that when we enter it into this machine and this operation is carried out, we end up with an undefined result? Now, undefined meaning that the result would be a division by 0. Dividing by 0 leads to an undefined result. Basically, we take the denominator and we set it equal to 0, then solve for x. So let's do that. What's the denominator here? The denominator is x minus 3, set it equal to 0, and then solve for x. Solving for x, we need to isolate the x. This will give us x on this side, since minus 3 plus 3 is 0, and 0 plus 3 is 3, and now we have 1x equals 3. So that's our solution. So he's saying here, if we enter 3 as the input value, we'll get an undefined result. We would not get a y value, so to speak. It will be undefined. Okay, so let's see. F of 3 is equal to 3 plus 5 all divided by 3 minus 3. 3 plus 5 is 8, and 3 minus 3 is 0. And of course, this is undefined. We cannot get a value for this. Right? Divided by 0. It's not possible. The value of x that will create this situation is 3. So, that's correct. Let's look at the next question. If f of x is equal to 2x plus 1 and g of x is equal to x squared, then what is the composite function f of g of x? We're trying to get to f of g of x. The first function is an f function, and we're inputting, so f function, and in the f function we're inputting the g function. So let's write the f function. The f function is 2x plus 1, so it's 2x plus 1, where x is where we'll have the input value. In this case, it's an expression, and so we're entering the expression for g, and the expression for g of x is x squared. So that means we're going to have 2 times x squared, which is 2x squared. Put back the plus 1. What's outside gets multiplied by what's inside. So this is just our solution. And so B is the solution. Number 4, for the function f of x equals 4x minus 8 all divided by x plus 2, the value of x that makes the function f of x equals 0 is, alright, so what is this saying? This is saying what value will we enter as an input value such that when we enter that value, the result will be 0. The output will be 0. So we input the particular x value, get a particular y value. What will be the x value we enter so that the output value would be 0? That's basically what it's saying here. Okay, so how do we do that? Well, just like with the denominator set to 0 to find the undefined result, to find the result that would make the function 0, we take the numerator. Since the numerator, if it's 0, divided by any quantity a, such where a is, the denominator is not equal to 0, by the way, 0 divided by any value will become 0. So it's the numerator that has to be 0, while the denominator cannot be equal to 0 in this case. So what we do with a question like this, step 1, we take the numerator and we set it equal to 0, then solve for x, because the numerator must be equal to 0. So this numerator here, we're considering it that it's equal to 0. Once it's equal to 0, dividing by whatever result this is will make the answer 0. And then we solve for x to find out what x value will be. Sweet. Now minus 8 plus 8 will give us 0, leaving us with 4x. So we have isolated 4x. 0 plus 8 will be 8. Then we divide both sides by the coefficient of x, which is 4. And this will give us x equals 2. Alright, so this will be the answer. X equals 2. Answer is A. Well, let's check. F of 2 is equal, so we input in 2 where x is. Alright, so we can place 2 wherever x is. So it'll be 4 times 2 minus 8, 2 plus 2. 4 2s is 8. 8 minus 8, all divided by 4, equals 0 divided by 4. And 0 divided by 4 is 0. So 2 is that input value that will give us an output of 0, which is exactly what we're saying here, right? So the answer is A. Moving along. What is the inverse of this function, f of x? Just like we did with a linear function. When I say linear, I'm talking about like a function with just 3x plus 2, for instance. But as long as you have a numerator and a denominator as expression, or you should just say as long as we have a division line here. Once it's a fraction, then it's going to be a rational function. So whether it's rational or linear, we take the function, the f of x part, and we change it to y. So this y we define this function with y. Alright, so y replaces the f of x. Then we change f of x to x. And we change the x's to y. Remember that? Yes. So the goal is to interchange x and y. Step 1, change f of x to y. Step 2, interchange x and y. Wherever we see y, we put x. Wherever we see x, we put y. Then, the next step, we're going to cross multiply. So here, we're going to multiply these guys and then these guys. So, we should have now x will multiply the binomial y minus 2. 1 will multiply the binomial 3y plus 2. Now, x times y by distributive property, or we call it distributive law, x times y will be xy, x times negative 2, negative 2x, result. Multiplying 1 by these quantities, we're going to get 3y plus 2. Since 1 is the multiplicative identity, anything times 1 give you back that same thing. Alright, next step. We want to remove this 3y from this side, so we're going to subtract it from both sides. So we're going to have xy, subtract 3y from this side, leaving us with just 2. And then we subtract the same 3y from this side as well. Grasp that? So what I just did, I subtract 3y from both sides. Okay, so this cancelled out. And so I have xy minus 3y on this side. But you might wonder, what happened to this? Well, I'm going to add 2x to both sides. So I'll have the 2x here. The order doesn't matter. I could say 2 plus 2x or 2x plus 2. The order doesn't matter. But it's nice to have the variable term first. Okay. So why did I do this? The simple truth is I just simply wanted the y terms together and all the other terms on the other side. And if you're confused about this step, here's a short way you could do it. Transpose 3y from being a plus 3y to a minus 3y. So from being a plus to a minus. Once you transpose over the equal sign, then transpose the minus 2x. Once it's moved from minus, it goes to plus. So the operation changes. So we have xy, the plus 3y becomes minus 3y, and the minus 2x becomes plus 2x. The operation changes. Then we put back the, of course, put back these because we didn't move them. That's a faster way of doing it or thinking about it. But truly what we really did was to subtract 3y from this side, so it no longer exists on this side, and we subtract it from this side, so we can see it here. We added 2x to this side to remove the minus 2x, and then we add it to this side as well, so you can see it here. Okay, so the next step after this is to factor out the y, doing the reverse of this distributive property. So since we have y here, we have y here and y here. If we factor it out, this is what it looks like. Y, open bracket, what we have outside is x minus 3. Okay, which is going to be equal to 2x plus 2. If you by distributive property, we can see we'll get back this. Y times x is yx, and y times 3 is 3y. Y times x is xy or yx. Alright, so the next step is I want to isolate the y. Notice y is multiplied by the binomial quantity x minus 3, so I'm going to divide by that binomial. The binomial into itself gives us 1. So we're saying 1 times y, which is still y. Oh, we have to do it to both sides. Never forget that. So it'll be 2x plus 2 divided by x minus 3. Now, this y here defines f of x. So this y defines the inverse of f of x. And so that's the solution we're looking for. This will be correct, definitely. Is there a faster way we could do it? Certainly. The faster way to do it is to identify these two guys here. So what we do, we change this to positive 2, change this to a negative 3, and then we swap them. So 2 will go where 3 is. As you can see, let's do it down here. F inverse of x. Let's put x here. Let's put this x and this positive 2 here. All right. So what are we swapping? All right. Remember I said this minus 2. Change it to a positive 2 and put it where 3 is. And this now we have a 3 here. I'm going to change its sign as well and put it where this guy was. So 3, change its sign to negative 3 and put it down here. And that's the solution. Much faster, right? And that's all. Sometimes you might see different signs in the solution. Just what you could do is just to check it to make sure. Like for instance, what you could do, change all the signs of all the terms, and that will be the same answer. For instance, this f inverse of x could be written as negative 2x minus 2 over negative x plus 3. What I just did, I changed all the signs, or the signs of each term. Then what you might find happening is that you find a solution looking like this: negative 2x minus 2, all divided by, and you can swap these around, put in the positive 3 first and the minus x after. But it's still the same solution. This here is the same as this. If you put a value for x, like 1, 2 or so, into this, you get the same answer as if you were to put it in this one. Hopefully that was helpful. Alright, determine the inverse of this function. So we have f of x is equal to, so we're going to change f of x to y, step 1. Wherever we see y, we put x. Wherever we see x, we put y. We isolate the y term, first of all, by removing it, removing the minus 7. This goes, and so we're left with 5y equals to x plus 7. Then we're going to divide both sides by 5. And so we have y equals the quantity x plus 7, all divided by 5. Now this y defines f of x, while this y defines the inverse of f of x, which is x plus 7 over 5. Okay, so this is the solution that we're looking for. And that's that. Now this one is not a multiple choice, so we had to write that out. Now if you look at this, alright, no, let's see if we can find a shorter way. No, notice that we start with x, we multiply by 5 to get 5x, then we subtract 7 to give us the quantity 5x minus 7, right? And this is what we refer to as f of x. Now if we want the inverse, what we do, we start with, just like we start with x here, we're going to start with x, going the opposite way. Instead of minus 7, put plus 7. And then, what's the reverse of multiplying by 5? Is to divide by 5. And so we use the previous quantity, x plus 7, divide by 5. And this is the solution for f inverse of x. Okay, so probably can have it like that. Okay, so we're seeing the same thing basically. So minus 7 becomes a plus 7, and multiplying by 5 becomes dividing by 5. Hopefully that was helpful. Alright, let's look at this one. We're to evaluate f of 3 being added to f of negative 1, and the function we're given is this. And so these are inputs. So let's see what we do here. We have the function, the particular function. Thinking of that function machine, right? And we're entering some values into the function machine. We're entering 3. We're entering 3. That's our first x value. So remember, what goes in our what? X value. What comes out is our what? Y value. Alright, so we enter 3. And what happens to it? Well, that x value gets squared, multiplied by 2, then added to negative 3 times that same x value plus 1, and then we get the output value. So we need to figure that out. Input 3, and this will give us the square of 3 is 9. So based on the order of operation, we want to do the powers before we do the multiplication. So square of 3 literally means 3 times 3, which is 9. Alright, here we have 3 times 3 again, which is 9. Now, we're multiplying 2 by the square of 3. 2 times the square of 3, or 2 times 9, is actually 18. when we have minus and plus, go in the order that we see it. 18 minus 9 is 9. And 9 plus 1 is 10. So we evaluated f of 3. F of 3 is the same thing as saying 10. Now, let us look at the next one. F of 1, negative 1. So now we're going to do is to input negative 1 into this machine and see what the output value will be. Alright, so we have, you're going to use the same function. Enter the value of negative 1. Alright, so we're going to square negative 1. So that's the same thing as saying negative 1 to be squared, which means negative 1 multiplied by itself. Negative times negative gives us a positive. 1 times 1 is 1. So that's be 2 times positive 1. Negative 3 times negative 1. Negative times negative is positive. 3 times 1 is 3. 2 times 1 is 2. 2 plus 3 is 5. Plus 1 is 6. So f of negative 1 is 6. Now what they want us to do really is to evaluate f of 3 plus f of negative 1. So let's write that. F of 3 plus f of negative 1. What is f of 3? F of 3 is 10. We put the plus sign. And f of negative 1 is 6. And so when we add f of 3 to f of negative 1, we get 16. So that's our solution. Okay. Now we're asked to find the value of x that makes f of x undefined. Now, is the solution correct? So let's see what you have here. 3x plus 1. And you set it equal to 0. That's correct. So we take the denominator. So the denominator must be 0 if it is to be undefined, right? If the function f of x is to be undefined. So the denominator must be 0. Since division by 0 will give us an undefined result. And then we solve for x, is what you did here. You added 1 to both sides. This is cancelled out, as I can clearly see. Alright, it's not 100% clear here, because it's like I'm seeing two equal signs. I'm seeing this and this as equal signs, so I would be careful of doing that. There should be a minus 1. Alright, and then I'm going to have 3x equals 0 plus 1, which is 1. Okay, so I could see that here. Just this portion that is not clear. Then we divide both sides by 3, which I can clearly see here, so this is correct. And then that will leave us with x equals 1/3. So yes, you're correct. It's just that this portion needs to be clear. It should be a minus 1. Find the value of x that makes the function f of x equals 0. Alright, so then we'll need the numerator. So the first one, so we should not do both of them the same way. 1/3 makes it undefined, since if we plug 1, for example, look at this. If we input 1/3, would it give us both undefined and 0? Because that's what we're saying here. So let's see which one. Alright. Now, 1/3 of 6 is 2, right? Since 2 added 3 times will give us 6. But we can just do it here. 1/3 times 6. 3 and 3 give us 1. 3 into that goes twice. That leaves us 2 over 1, which is 2. Alright, so that's be 2. Alright. We can say 3 and 3 give us 1. 3 into that goes twice. 2 times 1 is 2. And 2 plus 4 is 6. 3 and 3 goes once. 3 and 3 goes once. 1 times 1 is 1. And 1 minus 1 is 0. This is undefined. Alright, so we can clearly see that 1/3 only works for the undefined and not both. So what is the answer to this then? What's the value of x that will make the function equal to 0? So what we do here, we'll take the numerator. Remember, if we're dividing 0 by any quantity other than 0, we'll get 0. So it's the numerator that has to be 0. For if it's equal to 0, I will divide by that. Alright? We'll get 0. So for the solution for part B, this is part A, we set the numerator equal to 0. Not, in this case, the denominator, but this for the numerator being 0. Because subtract 4 from both sides. So we have 6x equals -4. And then we divide both sides by 6. This gives us x, because 6 and 6 give us 1. And we can simplify this. If we divide this by 2, this by 2, what would we get? -2 over 3. So x is equal to -2/3. Will produce that result. Okay, and let us check though. Let us see f of -2/3 is equal to, right, remember this function we're looking at, so it'd be 6 multiplied by -2/3 plus 4 over 3 times -2/3 minus 1. Now let us work that out. 3 and 3 give us 1. 3 goes into 6 twice. 2 times -2 is -4 plus 4. 3 and 3 give us 1. 3 and 3 give us 1. 1 times -2 is -2 minus 1. And this will be -4 plus 4 is 0. -2 minus 1 is -3. And 0 divided by any value other than 0 will actually be 0. So long as the numerator is 0, we get a solution of 0. So the value of x that created this is actually -2/3. So f of -2/3 give us 0. While for this one, f of 1/3 give us an undefined solution. In fact, it's not a particular solution. We do not know the solution. It's undefined. Cannot be defined. All right. So hopefully that's clearer. So just one more time. So this is not correct, right? That's not correct. This one, we have f of x is equal to 2x plus 1 and g of x equal to 3x minus 4. We want to find a composite function f of g of x. Is this correct? Okay, so let's see what we have here. F of g of x is equal to, so what we can clearly see here is that you do have 2, and this is actually representing x. So it's simply the same thing. So we take the g function, the f function rather. We're saying f of x equals 2x plus 1. F of x equals 2x plus 1. But where x is, we're inputting the g function, which is 3x minus 4, which is exactly what you did. Where x is, we put the 3x minus 4. Alright, and so that's correct. Then we distribute. 2 times 3x give us 6x, and 2 times -4 give us -8, then put a plus 1. And only the like terms can be simplified, so these are the like terms. We put back the 6x, and minus 8 plus 1 would be -7. Different signs, you want to subtract. 1 from 8 give us 7, and we have more negatives, so we put negative. That's correct. And the other way to look at this one is, now we want a g of f of x. So our goal is to write g of x first. And if we look at this, if we ignore this and put x there, then we have 3x minus 4. And 3x minus 4 is actually what? The g function. That's what's first, the g function. But where x is, what we want to do, we want to put what? The f function. And what's the f function? The f function is 2x plus 1. So where we have x, we put 2x plus 1, which is correct. So that's correct. Then we distribute the property. 3 times 2x is 6x, and 3 times 1 is 3. There's no x here, so it must be just 3. Put back the minus 4, and we have 6x, and 3 minus 4. Different signs again. We have a plus and a minus. So we say 3 from 4 is 1. We have more negatives, so our answer will be in negative. So this is correct. Right, so this is actually our g of f of x as a single expression. Or I could say as a composite function. If f of x is equal to 4x minus 5 and x plus divided by x plus 1, solve for x when f of x is equal to 3. Well, this is telling us that what is the value here that give us the output of 3. So we can't just take the output and put it here, which is exactly what was done. Notice you have the 4 and the 4 here, put the 3 here, minus 5. You put the 3 here and plus 1. So this would not be correct. This would not be correct, the correct step. Because you would be saying that this is the input. You're saying that x is actually 3. Right? Because what we're trying to do is solve for x when f of that same x value give us an output of 3. Alright? So you actually did it in reverse in a sense. What we're looking for is this x there, which is the same x here, that produce an output of 3. So we want to find out what is that x value. What is that same x value here? So in other words, again, the x here, here, and here, they're all the same things. What is that x that gives us 3 as an output? Okay, so let's find that out. What we need to do, what we could do, we could use the inverse. That's one way of doing it. Alright, that's one way of doing it. So there are two methods. F of x equals 4x minus 5, x plus 1, is to find the inverse. And with the inverse, we can input 3 into it. So we can put the 3 in, if we put the 3 into the whatever this is. So we know that f of x is 4x minus 5 all divided by x plus 1. So let's see what the inverse will be. Y equals 4x minus 5 over x plus 1. We change f of x to y, then we interchange. So we have done that, right? Interchange. So change f of x to y, then interchange. Where you see y, put x. Where you see x, we put y. Then we cross multiply, put x over 1, cross multiply. We can actually just do it right away. So we can say x times y is xy, and the x times 1 is x. Okay? Remember, we're going to multiply x by this binomial. So the x goes outside, and x times y and x times 1. Right. If you remember that from the previous examples. They're going to multiply these guys. Right? 1 times whatever is on top. And what's on top here is 4y minus 5. 1 times that binomial is just going to be 4y minus 5. Then after that, we're going to exchange these guys. So we have xy from a plus 4y to a minus 4y, and from a plus x to a minus x. Hope that is clear. Then we want to factor out the y. So if I'm going to factor out the y, what am I going to be left with? When I factor out the y, I'm left with x minus 4. If we use distribute property, y times x, we get back xy, and y times minus 4, minus 4y. So it makes sense. Then we want to isolate the y, so we need to divide by x minus 4, since it's multiplying y. It goes into self once. And so we have y equals negative x minus 5 over x minus 4. Then we find the inverse. Well, this is actually the inverse. So this y defines f of x, while this y defines the inverse of f of x. Alright, so what we can do, we can just write it here on this side. Now, here's what I'm going to do. I'm going to change, since they're all negatives, look a little bit awkward. So I'm going to change this to positive x, which means I have to change this as well in terms of the sign. I have to change these as well. So this x becomes negative x. And this minus 4, negative 4, becomes positive 4. A little cuter to deal with, right? Then what I'm going to do, alright, so this is my output function, or the inverse function. This is my output function, which means I can put the outputs into it to get the input value. Let's see, I'm going to take 3. So b here is actually 3. Alright, so if I want to go from the output to the input, I put 3 into this, and it will give me the input value. Let's see. Three plus 5 is 8. 4 minus 3 is 1. And so f inverse of 3 is 8 divided by 1 is 8. So the input value is actually 8. The input function, right? F of x equals 4x minus 5, all divided by x plus 1. Let's put the input value of 8, all right, in it and see what happens. Will we get an output of 3? Is this the true? Is 8 the true value of x to the output of 3? 4 8s, 32, minus 5, 27. 8 plus 1 is 9. 27 divided by 9 is 3. So that's correct. So it's f of 8, right? It's f of 8 that will give us a value of 3. So again, they're asking for what is that x value here that gives us 3. It's actually 8. Right, so the input value is 8, output is 3. Going from the output to the input, from output to input, we use the inverse function. That's one method. Alright, would you like to see the other method? Well, even though you might not be taught that method, I could show you how you could do that. Let's take a look. Alright, so what we could do here, let's look at it. So what we're given, we have f of x is equal to 4x minus 5 over x plus 1. And what we're told is that f of x is equal to 3. So what we could do, let's write equals f of x on this side. Is this true, by the way? Does it matter if I have f of x on this side or that side? No, right? So let's take it from there. And let's rewrite it again. This time, I'm going to change f of x to 3. Why is that? Because we're told that f of x has a value of 3. Now, I did not replace x with 3. I'm just saying the whole entire f of x is equal to 3. Not that x is 3, but f of x is 3. Okay, now that you get that 3 is the same as f of x, that means they're interchangeable. So I see f of x, I put 3. Now I'm going to solve for x. Put this over 1. Now 3 times this. Now 1 times this quantity here will be 4x minus 5. Agree? And 3 times this binomial, 3 times the binomial x plus 1 will be what? 3 times 1 and 3 times x. Correct? So 3 times x will be 3x, and 3 times 1 will be 3. So I could have just simply said 3 times the x is 3x, 3 times the 1 is 3. Then I'm going to, this 3x, I'm going to subtract it from this side, That leaves me, so it's gone. And I have 4x, I subtract it from this side as well. Which makes it look like as if it transferred from the plus 3x to the minus 3x. This minus 5 transferred to the other side, which means I'm going to add 5 to both sides, right? When I add 5 to this side, it's gone from this side. I add 5 to this side as well. Which means it looks as if it's transferred from minus 5 to a plus 5. Now, 4x minus 3x will give me 1x. And 3 plus 5 will give me 8. So, my solution here is x is equal to 8. So solve for x. Here's a solution. Much easier method. So all this is saying, again, we have our input, and we have our output. What is that input that led to the output 3? And the answer is 8. Remember, the input are x values, output are the y values. Okay. Alright, so let's move along though. Determine the inverse of this function. And hence solve for this. Now, we kind of do the previous one like that. Not kind of, we did. So let's take f of x. And we're going to find the inverse. Now, is this correct though? Well, I did say what we could do, we could switch. So this is this minus 2 and this 3 here, we're going to switch them. But change their signs and switch. Okay, so this negative 2 will become a positive 2 here by the where 3 is. So it'd be positive 2x, which you have, which is correct. But now the 3 will also switch. So this 3 becomes a negative 3 and goes where this guy is. But we do not have, we have a positive 3 here. That's the only thing. So there's something that seems a bit off. So let's check your steps to make sure what happened here. Alright, so we have, you wrote back the original function, which is correct. F of x equal 3x plus 2 divided by x minus 2. Okay, fine. Then you change f of x to y, and you wrote back the fraction, which is correct. All the terms look correct so far. You interchange x and y, where you have y, put x, where you have x, you put y. That is correct so far, nothing changed. Alright, so this part here now, you multiplied, let's say we have 3y plus 2. Okay, so you put this first. Right, so basically put it over 1. It's 1 times 3y plus 2. 1 times 3y plus 2 will give you 3y plus 2, which is correct. And on this side, you multiply x by y, which will give you xy. And you multiply x by negative 2, give it negative 2x. So this will be negative 2x here. So that's where the issue is. We gave a positive 2x there. Alright, so let's just clear up this section here. Alright, when you're doing it, you gotta be careful. Alright, just let's look at it. Let's change f of x to y. Interchange now. This becomes x. These x's become y. Alright, I'm going to take my time to do this. X times this. So best thing I would suggest is to, okay, let's put the 1 times this quantity first. I suggest you actually do this to avoid errors. Put the x down and multiply by this quantity. Actually write it down to avoid error. So 1 times this quantity will be the same quantity. Quantity is in the bracket, right? From the bracket. So 1 times 3y, 3y. 1 times 2 is 2. Then x times y is going to be xy. And x times negative 2 is negative 2x. Again, that's where your error is. You don't have the negative 2x. Alright, so Just do it like this to avoid losing a full mark for it. Or now, let's get the y's together. So I'm going to subtract the xy from this side and subtract it from this side as well. So that leaves me with 3y minus xy, which I see you have here, which is good. And then I need to add, well, I want to get rid of this. Since I have the y terms on this side, I want to remove this plus 2 with a minus 2. So I need to subtract 2 from both sides. And this will give me negative 2x minus 2. Again, that's where you have the error. You don't have the negative 2 there. The negative in front of the 2x. Okay, so now let's factor out the y's, right? But don't scratch them out, since this is part of this step. But factoring out the y's, I just want to show you what we'll be left back with, which is 3 minus x. Factor out the y, I have 3 minus x, which is equal to negative 2x minus 2. Then I'm going to divide both sides by 3 minus x. This to self goes once. So I'm left with y equals negative 2x minus 2 over 3 minus x. So this y defines f of x, this y defines the inverse of f of x. Alright, and let's see if you did this part correct. Now, it's a hence solve. Now when I say hence, it means you want to use the solution to the previous question. But you did not do that. You actually put the 7 in this. No, that's not what you do. It would not work. Because it's saying, what is the value of x? Here, what's the value of x? That you can put here, that will give you an output of 7. You can't put the same 7 there, because 7 is not the input. Right? 7 is actually the output. Okay, so you could put this 7 into the inverse function instead. And what it will do is give you the result you get will be the input value. Or you could do what I did previously using method 2. Alright, so that's the solution basically. Alright, so let's take that solution. Take the solution. So f inverse of x equals negative 2x minus 2. But remember, I also said if you have 2 negatives above, you can change all these guys to positive. So it looks a little, well, change to signs. Once it change, we have to change all the others. We have to change these as well. This will become a positive x. This positive 3 become a minus 3 or negative 3. Okay, so what I'm going to do now, I'm going to put 7 into this. 7 is an output. So put it in inverse in order for us to get the input. So I'm going to use this one. So it'll be 2 times that 7 plus 2 over 7 minus 3 is 14 plus 2. 7 minus 3 is 4. That's 16 over 4. Which is 4. So the input value is actually 4. Now we can test and see. Alright, 3 times 3x plus 2 over x minus 2 equals 7. Now if I put the 4 there that I got, will it work? Is x that 4? Alright, that's what they're asking us to solve. Alright, 3 4s is 12. 12 plus 2 is 14. 4 minus 2 is 2. And 14 divided by 2 is 7. So that's actually correct. So the x value is 4. So this is our input value. All right, that will go where x is to produce 7. Not 7 go into that same function to give us 7. All right, so that's one way to do it. Remember I said you could also do this as well. Right, this is a hence solve. So you want to use the inverse function. But the other method, which your teacher might not have shown you as yet, if you want to look at it, is this. This is hence solve this. Now we can solve this. Alright, we can simply say x minus, we can put this over 1, cross multiply. Alright, let's cross multiply this. 1 times this, we'll cross multiply these, we'll multiply. So it's 1 times 3x plus 2. I'm going to multiply these as well, which is 7 times x minus 2. So 1 times those will be the same thing, distributed in 1. 7 times x minus 2 will be 7x minus 14. And then we can subtract 3 from both sides. Well, 3x from both sides. Since this quantity is larger, I will get a positive that way, right? Positive 4x. And that would be 2 equals 14, 4x minus 14. Want to add 14 to both sides. That will give me 16 equals 4x. Dividing both sides by 4. I get x equals 4. Alright, so this is also not correct in terms of the approach. Right? This wouldn't be correct in terms of the approach. Alright, let's look at number 12. The function f of x equals 2x minus 5, g of x equals x squared, are defined for all real number x. Find f of g of x and g of f of x. Okay, so we're looking at composite functions here. F of g of x, we take the f function first. Well, what you have here is not correct. You're saying f of g of x is equal to this, but this is not f of g of x. This is actually f of x. So the way you set it up is important. So f of x is what's equal to 2x minus 5, not fg of x. You cannot put the g there. This is totally just f of x, okay? So once you insert the g there, you're saying that you have inside of f g. So inside of f, we're gonna replace that x. So inside of x, f, this is actually f. This function is f of x. So right now it's f of x, but we want to put g inside of it. And the function for g is x squared. So it's 2x squared minus 5. So while this is correct here and here, the initial part is incorrect, so you might lose a mark. Alright, next part. Let's look at g of f of x. Again, the way you set it up here, you lose a mark here as well, because that's not g of f. You cannot say g of f is equal to x squared and still saying it's equal to this. What's actually x squared? X squared is just g of x, the g function. That's equal to x squared. Once you combine it now with f, then you do an input. Alright, so we're inputting what? We're inputting f inside of g. So we have the x squared there, where the x is, we're going to make our substitution. And so f goes there, and f goes as 2x minus 5. And when you have this, you can't just square the two terms like that. This would not be correct to square just the 2x and then square the 5. So this part is also wrong. While this is correct, this part is wrong. This is actually what? It's saying 2x minus 5 multiplied by itself. Alright, so we're going to say 2x times 2x, which could be 4x squared. 2x times negative 5, negative 10x. Then we go from this one to this one. Negative 5 times 2x, negative 10x. And negative 5 times negative 5 will be positive 25. Negative times negative is a positive. Then that will give us 4x squared minus 20x plus 25. Same sign, add and keep sign. Alright, the faster way to do this, given you're squaring a binomial, call this a perfect square. Once you're squaring a binomial, we refer to it as perfect square. The rule is to square the first term. So we 2x times 2x is 4x squared. Then multiply 2 by the first term. Then multiply by the last term. Then you're going to add the square of the last term. Okay, so square the first, square the last, multiply the first by the last, and then double. Negative 5 times negative 5. Same thing that we have here, right? 2 2 is 4, 4 5 is 20, times x 20x. Positive and positive is positive, and positive times negative is negative. Same solution. So we're going to make a note of that, right? Why this is wrong. Okay. So again, you lose a mark here. Now let's evaluate the solution here. So this is actually be 4x squared minus 20x plus 25. This one is correct based on what it is. It's just that this part is not written correctly, as mentioned before. Alright, so let's put our solution. Now f of g of 3. So we know f of g of x is 2x squared minus 5. F of g of 3 will be equal to 2 times the square of 3 minus 5. Square of 3 is 9. I always want to do the exponent before multiplying. 2 9s now is 18 minus 5. That will give us 13. Okay, now g of f of 2. Well, we need to know what g of f of x is. And we got g of f of x to be what? As mentioned earlier. Now we can actually use this, right? We know that part is correct for sure. 2x minus 5 to be squared. So we can write g of f of 2. So it's going to be 2 times 2 minus 5, the square solution, right? So it's going to be 2 2 is 4 minus 5 to be squared. 4 minus 5 is negative 1 to be squared. And that's be negative 1 times negative 1, which is 1. So that's be our solution. And we can check it in the solution. If you put 1, if you put a 2 here, it definitely will not get the right solution. Yeah, so you did actually use g of f. You did actually use 2. There's a bit confusion here, because if this is 2x minus 5, but there's a square there which you missed in this one. So if you'd have squared this answer, you'd have gotten it correct. Alright, it'll be positive 1. So the part there is off. Alright, so let's look at it again. If I use the other one, remember I also said that g of f of x is 4x squared minus 20x plus 25. and we put g of f of 2 there. It's going to be 4 times 2 to be squared minus 20 times 2 plus 25. This will give us 4 times 4 minus 40 plus 25 is 16 minus 40 plus 25. And then we can do this. 16 minus 40, which would be negative 24, plus 25, which gives us positive 1. So we could use this version or the expanded version here. We still get the same solution, right? Alright, let's look at the next one. Now it seems as if there might have been more, because I see you also have f of, oh, you did, I see what you did. You actually did them in parts, like finding f of 2 first and then substitute it in. That's also possible, so we could look at that as well. Alright, so let's suppose we have f of g of 3. We know the f function is 2x minus 5, and the g function is x squared. So you can find the g of 3 first. So you have to be careful how you write this. Alright, so we find, because these two things are not equal. Alright, so that's equal sign, they shouldn't be there. Yeah, they're not equal. F of 2 is not g of f of 2. Okay, so what you want to do, and for this one as well, g of 3 here is not the same thing as f of g of 3. So if you're finding g of 3 first, you cannot put the equal sign there. So what you do, right, you can say, okay, well, you don't know the answer as yet, so you can leave that out. But you can, in a separate line, do not write equal sign. You put g of 3, and you find the g function, which is going to be x squared, so it'd be 3 squared, and this will give you 9. Now this 9 is only equal to g of 3, but you're saying that this 9 is equal to this and also equal to that. If that was the case, then you'd already found your solution, because you're saying f of g of 3 is 9, which is what they want you to find, f of g of 3. And it's not that it's not equal to 9, only this part is equal to 9. So the equal sign here is where you go wrong. So now we're going to find f of g of 3. Okay, so f of g of 3 is equal to f of g of 3. Alright, same thing. But we can replace the g of 3 with what g of 3 is. G of 3 work out to be 9. So now we can find f of 9, which is what you have here. But now this part is okay. Alright, so f of 9, looking at the f function, will be 2 times 9 minus 5, give you 18 minus 5, which gives you 13. So you lose a mark here, even though this is correct. And you will lose a mark here as well. Alright? Because that's not correct in terms of this statement, the equality. Alright, so let's look at the second part. So now, again, we have the g function. We want g of f of 2. So we know that it's the same thing as saying g of the input value, or the input being f of 2. Do we know what f of 2 is? Then we can replace it with a value. So we want to find f of 2 first. So we look for what f of x is before we can find f of 2. Just give you negative 1. So f of 2 is actually negative 1. So now we're trying to find g of negative 1. Alright, and so that means negative 1 goes into g. So we can actually do it either here, that's okay, the equal sign will be okay, because that's still g of f of negative 2 that we're doing. Okay, So g of f of negative 2, sorry, g of f of 2 is g of negative 1. Alright? Also, because this is negative 1, and then we still have the g at the beginning. Okay, so what is negative? What is g though? G is x squared. So what we could do, we could put with a square x, and what's the x value? The x value is this value here, negative 1. That's negative 1 times negative 1, which gives you positive 1. Okay, so g of f of 2 is actually positive 1. Alright, so we're at the last portion. Simplify h of x where possible. So we have h of x is equal to 2x squared minus 8 over x minus 2. Okay, so how can we do this? Since we want to simplify it, if you look at the top, we can actually factorize it. 2 can go into 2x squared and 2 can go into 8. So that's going to be inserted. It would be x squared minus 4 all over x minus 2. Now if you look at the top though, you'll notice that it can be factorized further, because x squared minus 4 is actually the difference of 2 squares. Alright, so we can write it as x plus 2 x minus 2. Recall this concept, that if you have a squared minus b squared, you can write it as a plus b as a quantity times a minus b. Okay? And that's exactly what we have here in terms of x squared minus 4. Because the 4 can be written as what? 2 squared. And so that ends up being x plus 2 times x minus 2. If we were to multiply this out, like in a times a, and a times b, then b times a, and then b times b, you end up with this solution here. Same thing goes for this. If you multiply it out, you get back this, which is essentially x squared minus 4. So all of that divided by, so x squared minus 2 squared, 2 squared is 4, will give us this portion. Remember the 2 is already there. We factored out. That results in this, and this part becomes this. Put this. Alright, so we have all quantities at the top being multiplied. Right, so it's 2 times this quantity times this quantity. Now once you multiply everything on top, you can cancel out now. This goes into self once, goes into self once, leaving us with 2 times the quantity x plus 2. So that is the simplified version of h of x. Alright, so now they're saying find the value of x that makes h of x undefined. In this form, of course, you would not be able to find it. So you'd have to use this form, because for it to be undefined, the denominator is what's equal to 0. So let's just clear the page. Alright, so looking at part B, we did part A already. Alright, like I said, it's going to be 2 times x plus 2. Alright, now for part, which is h of x, the simplified version. For part B, for it to be undefined, the denominator has to be equal to 0. So x minus 2 equals 0. Alright, so once we equate them equal to 0, we can find a value of x that will make that possible. Now x has to be 2 in it, because 2 minus 2 is what? 0. So if x is 2, then the denominator will be 0. Even though the numerator won't be, this will be 0. And dividing whatever quantity this will result in by 0 will be undefined. Alright, which is what we're saying. The value of x, we want to find that, which makes this function undefined. It will be 2. But let's see. If you add 2 to both sides, then we have x equals 2. Okay, so that's correct. Alright. Okay, the next one, state the solution of x when h of x is equal to 0. Alright, so sorry about this part here. So state the solution of x when h of x equal to 0. So h of x equals 0. What we're saying here. Alright, remember this, making it equal to 0. All we need to do is take the numerator. Take the numerator this time. Alright, because if the numerator is equal to 0, then it doesn't matter what this result in. Whatever, let's say it result in a value called a, 0 divided by a is 0. And then h of x here will be equal to 0. So what we're trying to figure is what is that value of x that will cause that. So we take the numerator, 2x squared minus 8 equals 0, and we solve. So we're going to add 8 to both sides. So we have 2x squared equals to positive 8. And then we're going to divide both sides by 2 to isolate the x squared. So we have x squared equals 4. Then we're going to square root both sides. Alright, the square root cancels out the square. So you leave back with x equals, and the square root of 4 is going to be positive or negative 2. If we put, let's try. Let's put h of 2 and see what happens. So 2 times 2 being squared minus 8 over 2 minus 2. So positive 2 does not work because we cannot divide by 0. Alright, we can divide by 0. Alright, so that does not make it equal to 0. Yes, we'll end up with a 0. So it's, for example, square root of 2 is 4. 2 fours is 8. We end up with 8 minus 8 divided by 0. We end up 0 over 0, which is also impossible. Alright, so this is indeterminate. So we can't have that. So even though the numerator becomes 0, 0 divided by 0 does not return 0. And I guess this is exactly the reason why it would be necessary to cancel out the denominator. Alright, so it is this one that we would need to set to 0. Alright, let's use a positive, the negative 2 this time, and see. So we have 2 times negative 2 squared minus 8 over negative 2 minus 2. Alright, and this will give us 2 times 4 minus 8 over negative 4, which gives us 8 minus 8 is 0 over negative 4, and this gives us 0. So only the negative 2 works. So our solution is only one solution basically. So this marked solution should be solution. So the solution would be x equals negative 2. As x equals positive 2 will not work. Alright, and that's why we check our solution, double check our solution. So this will be the correct solution. Now, of course, the fact that we would have cancelled out the denominator, and we end up with 2 times x plus 2, then we would have set that one to 0, and then find the value of x. Alright, so we divide both sides by 2. This cancels out, leaving us with x plus 2 equals 0. Then we subtract 2 from both sides. X equals negative 2. So this only has one solution. All right, so that's it. That's it for that one. So what the best thing to do is say state the possible solution or solutions of x when h of x equals 0.